We are trying to find the derivative of this function. I'll show you. So we originally get given this equation, and we say that's equal to the integral of whatever lowercase f of x is plus c. Okay? Now, they say find this one. All right? And we're also given what f lowercase is. So basically what they're wanting to say is, I want you to find the derivative of the integral. So really, this guy here is equal to the derivative with respect to x of the integral of tan dx. That's like a really fancy way and convoluted way of saying that. Okay, so using the fundamental theorem of calculus, you're going to integrate something and then differentiate it. So you're going to find the area under the curve, and then the slope of the curve is just equal to the same thing. Okay, perfect. That's half the battle done. To be honest, the most tricky bit here is just remembering the exact values. So hopefully you have a method of doing that. I personally prefer the table method. All right, I like using the table method to remember my exact values, but let's say you don't have it, right? And you're like, what is tan of pi on 3? So what's tan of 60 degrees? Well, here's the table method here. We start off with sine, we go to cos, and we go to tan. We start off with 0 degrees, then we start off with 30 degrees, then 45 degrees, then 60 degrees, and then 90 degrees. Okay, so I like using degrees, makes more sense. Now we just need to fill in the starting points and then of sine and cos, and then we can figure out the rest for tan. So let's draw to the unit circle, and it's got a radius of 1. Now we have to remember cos is about crawling, it's about the x-axis here. Sine is about touching the sky, the y-axis here. If we go 0 degrees, okay, then we end up at point, let's use a slightly different color. We end up at point 1 and 0. So that means that cos is equal to 1 and sine is equal to 0. Whereas if we end up at 90 degrees, pi on 2, that is equal to 0 and 1. So that means that sine is equal to 1 and cos is equal to 0. So let's fill that in on our table. So originally it's like this, and then it becomes like this. So now what we do is we divide everything by 2. And we have the square root. And what we do is we progressively go up from 0. So 0, 1, 2, 3. Then we go kind of like the other way. So we start off with 3, 2, 1. Okay, so that is all of your exact values for sine and cos. And then for tan, it's easier to remember it by saying that tan, by its very definition, tan is equal to sine divided by cos. Okay, so you can just divide them to figure it out. So let's do that for the first. 0 divided by 1. So let's say you've got nothing in your can, you've got absolutely nothing. Whereas if we break maths by going 1 divided by 0, put it in your calculator. I don't know what it is. Your calculator will say undefined. Now, the shortcut here is you say it's everything is root 3. And then you change the values here. So for me, it'll go minus 1, 0, 1. In this case, what we're after is pi on 3, which is this guy here, and we're after tan. So that means that we get root 3. Okay, so after all of that, That was just a method to create the table for you. So hopefully it's kind of easy to set it up. And then once you have that in your notes, hopefully you can just remember it by rote learning. You can also do the triangle, but I'll skip that for now in order for time for this video. So in this, we're trying to find what is pi on 3, so 60 degrees, and that is equal to 10 with pi on 3 in there, and we said that that's just equal to root 3. That is our answer. Let's go on to part B here. Part B is wanting us to find this. So it says find this guy. Well, we don't know what this lowercase f of x is, right? But we do know that when it's integrated, right, that's why the capital is given there. When it's integrated, it's equal to the square root of x. Cool. So let's take an easier example. Let's say I want to go from 1 to 4 for some function x for dx. Well, what happens is I find the integral of that, right? And I stick it in there. So really quickly, I stick it in there. And that's my integral. So really, this is the value of f of x. So it's already done part of the work for us. We don't have to find the integral of whatever the function f of x was. Who knows? Don't know what it is. So in essence, we can kind of skip a step to say that from 1 to 4 for this unknown f of x, this will be equal to root x. And that goes from 1 to 4. So now what we're saying is it's the top minus the bottom, right? It's that, I like to keep the square brackets around there, otherwise I'm likely to make mistakes. The square root of 4 minus the square root of 1. Now, the square root of 4. All right, what number times itself is equal to 4? That's just 2. What number times itself that's equal to 1? That's just 1. And so all of that is just equal to 1. And that is your answer. That's it. Easy as that.